Hi, welcome to Learning Monkey. I am Raghu here. In this class, we will discuss about checking a given linked list is palindrome or not. The explanation is completely based on the assumption that you already have some basic coding knowledge. If you are not good at basic coding, please watch our website learningmonkey.in. Take the course placement training for service-based companies, then come for the competitive coding. Coming to today's class, see, checking whether the given string is palindrome or not, the logic is very easy, but there is a difficulty with single linked list. What's the difficulty? We already discussed in our previous examples. Again, the same difficulty we are going to face here. Let's check what's the difficulty so that you will get used to that linked list examples. Given a single linked list of size n of integers, task is to check given linked list is palindrome or not. With example, we are going to check here 1 2 2 3 2 2 1. We need to check whether it is palindrome or not. It is a palindrome. Yes, our output should be yes. Usually, what's the logic to check the given string is palindrome or not? 1 1. First one, last one, same. Second one, last before one, same. Third one, last before one, same. Like that, we need to check the logic for the palindrome. But the problem here with single linked list is you can move forward, you cannot move backward because we don't have the address of the previous nodes in single linked list. So what we have to do? In our previous examples, what we have done? We can reverse the linked list, or you can go with the concept of a recursive function call. The same way we are going to do here, coming to the logic part. But you have, see, the time complexity of this program should be order of n. N means number of nodes in this linked list. And the space complexity should be order of 1. No extra space is needed. So you have to maintain the time complexity. So in order to maintain that, so the logic goes like this. Find the midpoint. What is the midpoint here? This is the mid node. From here onwards, this is second half, this is first half. Reverse the second half. When you reverse the second half, what is the second half? 2 2 1. When you reverse it, 1 2 2. Now you have the starting address node and the second half address node. Check the two halves. 1 2 2 3 1 2 2. Take two pointers. Check the two halves one by one. If all are same, say it as palindrome. Otherwise, no palindrome. And reverse again. The second half should be reversed again. This is the first logic, and we are going to discuss one more thing, finding midpoint. So we are going to use a new logic here in order to find the mid value. How we are going to use that? Let's understand it. This helps in many of the examples. Previous examples when we discussed about finding a loop in the linked list, we used a concept called slow pointer and fast pointer. Means take two variables, slow pointer and fast pointer. Slow pointer moves one step, fast pointer moves two steps. So in order to find the midpoint, both slow pointer and fast pointer starts here. Take a loop. Slow pointer take one step, fast pointer take two steps. Whenever the fast pointer went to the last node, the slow pointer will be at the middle point. In order to identify the middle point, we are using this concept. So identify the midpoint, reverse the second half, identify both are palindromes or not, then reverse it again. This is the logic. So below we provided the code also. Before that we will understand the second way. You try to solve the second way on your own. So in our last class we discussed that in this linked list examples we go with recursive function call because we start from here. First function call this node, second function, next function until none. Because recursive function calling itself, it works as a stack. Last function points this node, before function points this node, before function points this node, before function points this node. You stop until you found none. We take a global variable left. Why we are taking global variable? Because the last function pointing is this one, but we need to check this one with the first node. That's why we are going to take a global variable left. Left points to the first node. In the recursive function call, the local variable right points to the last node and the global variable left points to the first node. Check both are equal or not. Stop this function. Before function, what's this function is going to point? This node. So we need to update the left variable. Left is a global variable, we can use it. So update to the next one. Like this, please move on. Left will be moved on, and each time we are going to check using recursive function call. We are going to check this node, this node, this node, this node. Like that we are going to check. This is the second way using recursive function call. Now coming to the coding part. The coding part is available in our website learningmonkey.in. You can copy the code and use the code from our website, or our suggestion is try to solve it on your own. This is the coding part. Hope you understand the logic. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.